Okay, in this video we're going to continue our discussion of the method of undetermined coefficients. And last time we talked about what to do. So last time, actually it's just right above. I'll just go over it. So the general question is, what do you do to find a solution to this differential equation where you have second order linear constant coefficient differential equation where the function on the right, so when it's a y double prime plus by prime plus cy equals some function, when this function involves polynomials, exponentials, or sines and cosines. And for polynomials, that's what we talked about in the previous video. So if you have a polynomial of degree n as your f of t, then your yp is going to be a polynomial of degree n, the general polynomial of degree n. And but you may have to multiply by t or t squared, depending on whether r equals 0 is a single root of the equation or a double root of the equation. So if r is not a root of your equation ar squared plus br plus c equals 0, right? If 0 is not a root of that, then you don't have to make any modifications to your initial yp. Your yp is going to work without multiplying by t or t squared. But if 0 is a root, so that's if you have your c is equal to 0, then you have to multiply by t if b is not equal to 0. If b and c are both equal to 0, then you have to multiply by t squared. So that's how you handle a general polynomial on the right for your f of t. Now let's talk about what to do when you have exponentials. So in other words, e to the rt. Okay. So when you have something like this, a y double prime plus by prime plus cy equals a constant, say c, capital C, e to the rt, so that's your f of t, then what happens is if r, what you do is if r is not a root of the polynomial ax squared plus bx plus c, okay, then your yp that will work is just a constant, say a e to the rt. This will work. Okay. If r is a single root of this thing. Okay, so let's just recall what that means. So in other words, this polynomial ax squared plus bx plus c factors as a times x minus r times x minus something other than r, say s, and r is not equal to s. So if you have something like this, okay, then what you have to do is you have to multiply your initial yp by t. So then yp equals a t e to the rt will work. Okay. And then the other possibility is if r is a double root of ax squared plus bx plus c. So in other words, your polynomial ax squared plus bx plus c factors as a times x minus r in parentheses squared. So if you have something like that, then you have to multiply your a e to the rt by t squared. So then it's going to be a t squared e to the rt will work. So notice that you don't actually have to make any guesses for what's going to happen. the yp that will work depends on whether your r, so your r being this r here, whether that r is a root. So if it's not a root, you don't have to modify your yp. If r is a single root, you have to modify your yp by multiplying by t. And if your r is a double root, then you have to modify your yp by multiplying by t squared. Okay? So for instance, let's do an example. Let's just do an easy one. So let's say that you have this question which is to find a particular solution. So again, that just means find one solution. You don't have to find all the solutions, you just have to find one. Find a particular solution to y double prime minus 4y prime minus 12y equals 3e to the 5t. Okay. So your r in this case is what? Is 5, right? And what's our polynomial? It's x squared minus 4x minus 12. So first of all, is 5 a root of this polynomial? 5 squared minus 4 times 5 minus 12, is that 0? Well, you get 25 minus 20 minus 12. That's not equal to 0. So r is not a root of this polynomial. So therefore, what's your yp going to be? It's going to be a e to the 5t. Now notice that this 3 doesn't play any role in your yp. Okay? I mean, it's going to affect the a, right? It's going to affect the answer that you get for your yp, but it's not going to affect the fact that you use ae to the 5t. The only thing that matters for figuring out what yp will work is going to be like the form of the solution is what your r is. Your r is 5, and then how that's related to the polynomial you get. So this is the form of the particular solution, right? It has this form, a e to the 5t. But the question is to figure out what your yp is going to be, and so to do that, you have to actually figure out what a is going to be. So let's take the derivatives. So yp prime is 5a e to the 5t. Your yp double prime is going to be 25a e to the 5t. And now let's plug everything in. So you get 25a e to the 5t minus 4 times y prime, that's 5a e to the 5t, minus 12 times y, so that's 12a e to the 5t. Now what is this going to be? I can factor out an e to the 5t, and I'm going to get 25a minus 20a, right, because of the 4 times 5 here. So I'm doing this. So I get a minus 20a here, and then here I get a minus 12a. So I get minus 12a. And what am I going to get when I do this? E to the 5t times negative 7a. So negative 7a e to the 5t. Okay, that's what I get when I simplify. So this is my left-hand side. So I set this equal to the right-hand side, because I'm trying to figure out what a is going to work. It should be equal to 3a, it should be equal to 3e to the 5t, no matter what your t is. So now you set the coefficients of e to the 5t together, right? So negative 7a is going to be 3, and so therefore a is going to be negative 3 over 7. So our yp is going to be negative 3/7 e to the 5t. And you can actually check if you wanted to, that this function really is a solution to this differential equation. Okay. Let's do another example. So find a particular solution to y double prime minus 4y prime minus 12y equals e to the 6t. Okay, so our r is going to be 6, and our polynomial is x squared minus 4x minus 12. And is 6 a root of this equation? Well, when you plug in 6, you get 6 squared minus 4 times 6 minus 12. And this is 36 minus 24 minus 12, and that is in fact 0. So r is a root. Now you have to ask yourself, is r a single root or a double root? Well, so now you have to do some factoring. This polynomial, is going to factor as x minus 6 times x plus 2. So is r equals 6 a single root or a double root? It's a single root, right? Because a double root would be if you had x minus 6 in parentheses squared. We don't have that. So we have a single root, and so what's our yp going to be? We should use yp equals a times t e to the rt, which is, so you get a t e to the 6t. If you think about what's going to happen, if you try a e to the 6t without the t, okay, just a e to the 6t, if you think about it, we know what's going to happen because we've solved the homogeneous equation. We know that that's the solution to the homogeneous equation. So if you figure out the left-hand side, you're actually going to get 0. You're not going to get the function e to the 6t. Okay? So, I mean, one way to think about why we have to multiply by t is that a e to the 6t isn't going to work because we know that's a solution to the homogeneous equation. Right? That's going to give you 0 on the left, but we're trying to get e to the 6t. So this is what we use. This turns out to work, right? You're going to be able to solve for a by doing this. And now we have to find what our yp actually is. We have to know what a is. So we're going to have to differentiate. For that, we'll use the product rule. So we will move the a out and then use the product rule with t and e to the 6t. So I'm going to get 6t e to the 6t plus e to the 6t. And I'm going to need to take the second derivative. So let's take the second derivative. You're going to get a times see, this is one of those things where it might actually be easier to simplify the yp first before differentiating again. Because on the inside, I can factor out an e to the 6t, and I'm going to get 6t plus 1. So why don't I take the product rule with this instead? So I'm going to get, I can pull out the a again and then use the product rule. So I'm going to get 6 e to the 6t times 6t plus 1 plus 6 e to the 6t. Hold on. okay, I'll do the first function times the derivative of the second, so it's e to the 6t times 6, and then plus the second function, 6t plus 1, times the derivative of the first, so I'm going to get 6 and then e to the 6t. There we go. So our yp double prime, let's simplify this, is going to be, so we have to multiply all of this out. So we're going to get, okay, let's gather the highest terms together. So you're going to get a t e to the 6t here, right? So you're going to get a times 36t e to the 6t. And then you get a e to the 6t term here and then one here. So you're going to get 6 e to the 6t plus 6 e to the 6t makes 12 e to the 6t. So this is going to be 36a t e to the 6t plus 12a e to the 6t. Our y prime is 6a t e to the 6t plus a e to the 6t. Okay? So now we plug all these things in to the left-hand side. So I'm going to get, second derivative is 36a t e to the 6t plus 12a e to the 6t minus 4 times 6a e to the t e to the 6t plus a e to the 6t minus 12 times a t e to the 6t. Okay, let's simplify this. This is going to be, okay, let's gather the t e to the 6t terms together. You're going to get 36a minus 24a and then minus 12a. Oh, that actually ends up being 0. Okay. And then what about the plus e to the 6t terms? So you're going to get 12a and then minus 4a, and that's it. So this is going to simplify to 8a e to the 6t. And we want this equal to, so set this equal to, so that's the left-hand side, 8a e to the 6t, and then the right-hand side is going to be e to the 6t. Well, that tells you that 8a is going to be equal to 1, right? So that implies that a is going to be 1 over 8. So our yp is going to be 1/8 t e to the 6t. So that's exponentials. Did I explain that you have to multiply by, yeah, I did. You have to multiply by t squared when r is a double root, right? I'm not going to do an example of that, but this is what you would do. And well, maybe we'll just do a quick example. So instead of actually kind of doing an entire calculation all over again, let's just talk about what you would make your yp equal to. So find the form of a particular solution to y double prime plus 8y prime plus 16y equals 7e to the 4t. 7e to the minus 4t, sorry. So when it says find the form of a particular solution, right, that just means say what format yp is going to have. it doesn't mean solve the differential equation. Okay, it doesn't mean actually solve for your yp. You just have to say what format it has with the coefficient, but you don't necessarily need to say what the coefficient is. So in this case, our r is -4. And our polynomial, ax squared plus bx plus c, is x squared plus 8x plus 16. Well, we know this factors as x plus 4 in parentheses squared. So this time r is a double root, right? R is a double root. -4 is a double root of x squared plus 8x plus 16. So what's our yp going to be? It's at squared e to the -4t. That's the form of a particular solution. Okay, and if you wanted to, right, well, it doesn't say to actually figure out what your a is, but if it asks you to find a particular solution or find one solution to this differential equation, then you would have to do what we did before, take the derivatives, plug it in, set the coefficient equal, and then solve for a. Okay, so that's what happens if you have an exponential as your f of t. And then for sine and cosine, so let's say that you had, again, ay double prime plus by prime plus cy equals f of t, and f of t was something that was like c times sine of beta t, or c times cosine of beta t. Then it turns out that if you use yp as a sine beta t plus, say, capital B times cosine of beta t, this will work. So you need a sine term and a cosine term. And also, the coefficients have to be different. Okay? So it's not going to be a times parentheses sine beta t plus cosine beta t or anything like that, right? It's not a sine beta t plus a cosine beta. It's one constant for sine beta t plus another constant for cosine beta t. Now, they might turn out to be the same, but in general, they will be different. So let's do an example of this. Find a particular solution to y double prime minus 4y prime minus 12y equals sine of 2t. Oh, you know what? I think in this case there might also be an issue if 0 is the root of the, let me think. Yeah, you might actually have to multiply by t. Okay, so let's say if b and c are not 0. In this case, b and c are not 0, right? So our particular solution is going to look like yp equals a times sine of 2t plus b cosine of 2t. Okay, so now we take the derivative, and we're going to get 2a cosine of 2t minus 2b sine of 2t, right? And when you take the second derivative, you're going to get negative 4a sine of 2t minus 4b cosine of 2t. So now we plug everything in, we're going to get, in fact, it might be easier instead of writing it all out to just group the sine 2t terms together. Let's see, do I want to write it all out? Yeah, okay, I guess I will write it all out. Negative 4a sine of 2t minus 4b cosine of 2t minus 4 times, I'm going to multiply the 4 out. So I'm going to get negative 8a cosine 2t and then plus 8b sine of 2t, because I'm multiplying the negative 4 here by the negative 2b, and then minus 12 times a sine 2t plus, minus 12b cosine of 2t. So that's the thing on the left. And this is going to simplify. Let's gather the sine of 2t terms together. You're going to get negative 4a plus 8b minus 12a. Right? So negative 4a plus 8b minus 12a. And then for the cosine 2t term, I'm going to get negative 4b minus 8a minus 12b. So this is going to simplify to negative 16a plus 8b times sine of 2t, and then plus negative 8a minus 16b times cosine of 2t. So I set this equal to the thing on the right, which is sine of 2t. Now I set the coefficients of sine 2t and cosine 2t together. So I get negative 16a plus 8b is, no, it's 1, right? Because it's 1 sine of 2t. And then negative 8a minus 16b is 0. Because what I have is sine of 2t. This is 1 sine of 2t plus 0 cosine of 2t. Okay. So now I have to solve this. And I can solve this by multiplying I can multiply the first row by 2, the first equation by 2, because I can then add the equations to cancel out the b's, right? So if I multiply this first equation by 2, then I'm going to get a 16b, and then I can, when I add the first equation to the second equation, I'll get the cancellation with the b's. So let's multiply the first equation by 2. Negative 32a plus 16b equals 2. Negative 8a minus 16b equals 0. Then I add the two equations together, and I'm going to get negative 40a equals 2. So now I divide both sides by negative 40. I get a is negative 1 over 20. Then when I substitute into either of the equations, I get, let's plug it into the second equation. So I get negative 8 times negative 1 over 20 minus 16b is 0. And that's negative 16b equals 8 over 20. No, negative 8 over 20, right? And then I divide by 16, so I get negative 8 over 20 times negative 1 over 16. And I can cancel out the negatives, and then 8 over 16 is 2, so I get 1 over 40 for B. So my final YP, finally, is going to be negative 1 over 20 sine of 2t plus 1 over 40 cosine. Is it 2t? Yeah. Plus 1 over 40 cosine of 2t. Okay. I have to double check, but I think when 0 is a root of the equation, then you might have to multiply by, let me think. Well, I don't remember off the top of my head, but basically, you need to make sure that your things are not solutions to the homogeneous equation, right? Because didn't we have a scenario where you have something like this? We had a scenario where you had a homogeneous equation and the solution ends up looking something like this. Okay. So if that happens, you have to multiply everything by a t. In a future video, I'll clarify this. So we talked about exponentials, what to do when you have an exponential, right? It's pretty straightforward, depending on whether r is a root, a single root, or a double root. And then when you have a sine or cosine, then you just, as long as the thing is that you just don't want your YP to be a solution to the homogeneous equation. So let's see, when do you get a sine of 2t as a solution to the homogeneous equation? See, so here you have, like, remember it was like e to the alpha t sine of beta t. So here your alpha is 0 and your beta is 2. So basically it's okay, let's just not pay attention to this. It's if alpha plus or minus I beta is not a solution to ax squared plus bx plus c equals 0. When that happens, then you don't have to multiply by t. Okay, but if it is a solution, then you have to multiply by t. And what will happen, you don't even have to do all of this out, because if you try your YP, your initial YP, okay, it'll be very clear because you'll get 0 on the left. So basically, you make your initial YP equal to this, and then if the thing on the left is not 0, then it's going to work. But if the thing on the left is actually 0, then you have to multiply your initial YP by t. Because otherwise you're going to end up getting the homogeneous solution instead of the inhomogeneous solution. Okay, in the next video we're going to do some more examples of this, and then we're going to talk about what happens if you have a sum of terms. So what if instead of sine of 2t you had sine of 2t plus e to the t or something like that? We're going to talk about what to do, and then we're also going to talk about what happens if you have e to the alpha t times sine of beta t, or e to the alpha t times cosine of beta t.